So the first place to start is we have to start with a needs assessment. We have to actually understand how much cooling do we require to meet the Sustainable Development Goals. Until people understand how much cooling that requires, you cannot start to answer the questions of how we deliver it in a safe and environmental way.
And I'm very pleased to be here now with Professor Toby Peters joining from UK. Toby, welcome to Atmosphere Asia. It's very early for you this morning, so thank you very much for joining us. I believe it's 6 a.m. in UK. So thanks a lot. How are you doing this morning? I hope you have a good coffee next to you.
Yes, I've just had a good coffee. Yes, it's 6 o'clock in the morning. There's a bit of a storm outside, but all good and very excited to be here with you today.
Fantastic. Thank you very much again. Hopefully it's not as bad as the typhoon that passed Philippines just a couple of days ago.
No.
Again, for joining. So with that, we're very pleased to have Professor Toby Peters. He has been an active advocate of the clean cooling technologies, very involved in cold chain. He's a professor in the cold economy at the University of Birmingham. And again, he's a true expert. And today he will share with all our delegates about the clean cooling. What is clean cooling? Why it matters? What is the implication of improving of cold chain infrastructure around the world? So we have a lot of interesting content to be presented by Professor Toby Peters. And with that, I would like to give the word to Toby. And of course, everyone is free to welcome to submit your questions. We'll have about 10 minutes to address some of them after Toby's presentation. So welcome again, Toby, and the virtual floor is yours.
Thank you very much, and thank you very much for inviting me here today. So, access to cooling. Access to cooling isn't a luxury, but it's absolutely critical to human well-being. It's about fresh, nutritious food. It's about safe medicine and vaccines, and it's about protection from heat for populations in a warming world. It's vital for our economic productivity. If you look at, say, sub-Saharan Africa, about 54% of the workforce relies on agriculture. 80% of Africa's farms are less than 2 hectares, yet deliver 70% of the continent's food. And yet small-scale farmers are unable to cool produce immediately after harvest and in transit, and they lose about 35 to 50% of high-value temperature-sensitive horticultural and dairy produce. According to the World Bank, in Rwanda, food loss represents about 12% of the annual GDP. It's about 21% of total land usage and contributes 16% of the country's greenhouse gas emissions. So that's just one example of how reducing food loss is really important. It's also important as we look forward, because in a world where climate change is impacting food cycles, deteriorating arable land and reducing water availability, you know, for me, food saved is as important as food produced. But how we meet this challenge and provide access to cooling for the benefit of all who need it will have important ramifications for our climate. So universal access to clean cooling is a multifaceted challenge. How do we meet urgent global need for cooling for the benefit of all, but without overheating the planet? And there's a new challenge. Vaccines, for the majority of the people of the planet, pose an extraordinary new challenge to all countries around COVID-19 and the delivery of it, but particularly in low and middle income countries where the current cold chain network isn't capable of meeting current demands, let alone handling extraordinarily large quantities of the vaccine in a short space of time, whilst maintaining existing immunization needs. So central to any vaccine distribution plan will be the cooling equipment and cold chain infrastructure, which in the developing world will require re-engineering and significant new capacity. And recent estimates, just to put this in context, indicate that more than 25% of some vaccines may be already wasted globally every year because of temperature control and logistics failure. And we're talking here about trying to vaccinate maybe 5 billion people with 2 doses, so maybe 10 billion vaccines need to be moved. And whilst the cold chain, therefore, is an integral part of achieving our immunization targets for COVID-19, it comes with an environmental cost. It uses energy, it uses often high GWP refrigerants. So given most of the technologies deployed will still be in operation in the next decade at the minimum, it's it's imperative to recognize that new cold chain capacity shouldn't just be built on technologies that are affordable, but are environmentally harmful and hinder the world's ability to hit our targets related to the reduction of emissions and GHGs and other pollutants. So just quickly as an overall, what's this all about? If we deliver access to cooling for all who need it, we will probably need to deploy by 2050 14 billion devices, contributing about using about 19,000 terawatt hours of energy. To put that in context, if we want to meet the agreements of Paris climate change, then we need to retain or keep the target for cooling to about 6,200 terawatt hours. So that's the challenge. How do we deliver the cooling for all, which requires in current business as usual about 19,000 terawatt hours of energy for less than 6,200? For me, the big challenge is that when people talk about energy, they often mean electricity. When they talk about energy storage, they mean batteries. And this blurring of concept matters because it fails to recognize that a large slice of our consumption of energy comes in the form of thermal energy, and that the fastest growing sector of energy demand over the next 20 years, if not the century, will be for cooling. And that cooling would be better served by energy carriers other than electricity and batteries. So in short, we have to stop to think about how do we green electricity, but rather we have to start thinking thermally and thinking about how do we green our energy demand. And the key question within that is that we have to change the question. So it's not about how much electricity can I green. It's about what is the service I require and how can I deliver that in the most energy efficient way. We have to think about how do we make energy, how do we use energy, how do we move energy, how do we store energy, how do we manage energy, and how do we finance energy. We have to start thinking about it at a systems perspective. And for me, there are 3 stages of action we've developed. I'm working on this with Sustainable Endure, and we've developed a 3-stage roadmap to support the deployment of sustainable cooling. The stages of action really aim to deliver the quick wins that are possible in the short term, while simultaneously accelerating that needed step change innovation that will deliver long-term systemic changes. The key for me to a successful outcome is to ensure that the short-term wins are aligned with the long-term ambitions, and equally the long-term ambitions don't constrain the short-term deliverables. The first stage of the roadmap is what I call readiness and quick results. And this includes establishing a collaborative consensus view of the system of systems alongside implementing the low cost and here now impact solutions for quick wins aligned to the vision. And it's about establishing the longer term foundational and enabling solutions such as policy planning, regulations, education, training, and institutional capacity building that increase preparedness. The second stage is market transformation and scale up, but which includes aggregating need, wider deployment of natural and passive cooling designs, as well as highly efficient low GWG technologies with the help of enabling solutions, the policy, the regulation, the financial that we've already put in place. This stage will require significant financial resources, as well as strong public engagement and political commitment to bring cooling into the rural communities as well as into the cities. And the third and final stage is then the emergence of a sustainable cold economy, which sees a clear, optimized, sustainable cooling system of systems that establishes and harvests all the waste thermal energy resources we can, that fully leverages synergies between subsystems, that utilizes natural cooling, passive technology and renewables, and ensures full access to cooling for all who need it and depend on it for their economic health and safety. So the process starts with, for me, the needs assessment. And for a government to ensure that the cooling needs of their population are met equitably and sustainably, including for the most vulnerable, they first of all have to understand what these needs are around health, food, productivity, and safety. For example, actually, how much cold chain would be required to enable farmers' incomes to double by 2025, or to end hunger and malnutrition? How much cold chain is needed to provide access to vaccines? The very question people are now answering around COVID-19. And it's not simply about what is the projected growth, it's how much is required to meet the Sustainable Development Goal. How much degrees of cooling comfort is required to avoid heat stress at home or in the workplace? So what needs must be met in the country to meet the Sustainable Development Goals with no one left behind? And an underestimation of the scale of the cooling demand and its impact on the energy consumption risk contributing to a lack of ambition in policies, infrastructure and technology developments, as well as capacity building. It will ultimately have far-reaching social, economic, and environmental impacts because we don't understand the size of the problem we're trying to resolve. We've developed at Heriot-Watt, where I also work, with Sustainable Energy for All, a first-of-a-kind cooling for all needs-based assessment and methodology, which is about aligning the cooling action plan, the needs, to the United Nations Sustainable Development Goals, to understand cooling needs and the gaps for all key sectors: thermal comfort and safety, food and health. And one thing I just want to say is that, importantly, if you focus on per capita equipment penetration rates at the beginning, that presupposes a top-down technical solution to cooling. And that ignores the possibility of electricity demand mitigation through the redesign of systems, the aggregation of demand, the modal shifts, the use of waste or currently untapped resources, as well as support for existing cooling practices and behaviours. So this is why, in my view, it's so important we don't start with what's the equipment projection, but we actually then start with the key question: what's the need we're trying to solve? And then building on that, we're also launching a toolkit to actually help people design how do they solve this problem. It takes a whole system, holistic approach to integrated coordination of planning, implementation, business models, and system management. So after identifying the needs in each sector, the next step is to begin to explore how to use and mitigate use, that's really important, make, store, move, manage cooling within the boundaries of the energy and thermal resources available, the GHG emission targets, and other sustainability goals, as well as the costs. And the first layer of classification is, for me, protect, reduce, shift, improve, and aggregate. And whilst avoid, shift, improve are already in use, this framework, I think, expands the concepts further in recognition of the needs of vulnerable populations, with protect as the starting point, and the approach for delivering the solutions, and aggregate as an effective means for achieving impact. The start point in this process, though, has to be reduce. to determine areas for intervention that protect the vulnerable groups, but reduce the need for mechanical cooling at the same time. And then at the end, there are a range of levers that can be grouped, I think, into 5 solution categories that together can meet the needs for cooling. And we can further define components of these categories into two subcategories: direct solutions and enabling solutions. Direct solutions are those where the actor can effect a change through a direct action, such as something as simple as a temperature setting on an air conditioning unit, or making a technology choice, and encompass behavior, technology, and services in the operation actions. Enabling solutions are those where the actor provides a supporting environment, such as creating a regulation or funding model, and includes policy and finance. And here there's some overlap because also it includes services, particularly around training, which is essential. So whilst technology solutions are the first types of solutions that come to most people's minds when thinking about the best way to go, we have to have a combination. We have to have the policy and the finance as essential to build the enabling environment. And yes, we have to have the training. There is no point, as we look to solve COVID-19, for example, and the immunization challenge, of deploying so much equipment unless we deploy the training and the people to maintain it. Just a couple of things. Picking up on the aggregation is a project we're doing, which is around community cooling hubs. And this aims to develop an innovative and community-based solution to meet rural cooling needs. And our view is that by aggregating demand to optimize system efficiency and resource management and bundle revenues. So how can we meet the need for farmers and fishers to reduce post-harvest food loss, protect the quality and value, and provide new distant market connectivity. But at the same time, by aggregating the cooling service, we can at the same time potentially also meet the need for the vaccine distribution. And we can also just do very simple things around thermal symbiosis. So the back end of a cooling device is heat, waste heat, which we can use to provide drying or hot water. So by looking at this at a community cooling hub perspective, we think there's the opportunity to create environmental benefit and also to create the financial aggregation of services to deliver the economic sustainability. The final piece of the jigsaw then is that we are developing an audit and assessment process. And the objective of this is to set and uphold the standards that establish the foundations for meeting the goal of net zero carbon, while simultaneously recognizing the economic benefit of clean cooling and the social environmental gains that can create strategic value and foster economic growth. So the aim is to systemically understand, quantify, and audit the social, economic, and environmental value of cooling projects, systems, and systems of systems to provide an assessment of their credentials. Basically, it asks a series of questions, and the answers to those questions enable cooling projects to be audited by a variety of stakeholders, including the users, governments, planners, and also the financiers. And we think the advantage of this will be that it helps us really understand and meet the societal and individual cooling needs. And also, as I said, enable the investors to ensure that they are supporting clean cooling technologies and solutions, not just greenwash. And we aim to launch this as being peer reviewed before the end of the year. So how do we deliver this? Well, one of the projects we're doing in Africa is with the government of Africa and a group of UK universities supported by DEFRA and working with United for Efficiency, is the development of a new centre of excellence for sustainable cooling and cold chain. Yes, this will deploy and demonstrate technology, but it will do much more. It will also give the support to help design the business models, to provide the training and resource around the clean cooling technologies. So it's an integrated approach, we think, to deploy technology with the training, the business model development, the measurements and the systems. And we're looking for this to be go live in 2021, as I said, with the funding from DEFRA. It will have big impact because it will be looking at the holistic demand of nutrition for all, doubling farmers' income. It will recognize as a community cooling hub the need for vaccines and other services. And it will also act as a hub for living labs to be deployed elsewhere and cascade the knowledge out into other markets. So I think that's a really exciting program of how we take the idea and then deliver it right into market by collaborative working. So in conclusion, in a warming world, access to sustainable cooling isn't a luxury. It's an issue of equity, and it's a service that we have to deliver for all. Cooling doesn't just mean an air conditioner or a refrigerator in every home. It's about providing more sustainable and affordable solutions to address the needs of the vulnerable, such as access to nutritious food and safe medicines. We will not address COVID-19 without cooling and access to cooling for all. Clean and sustainable cooling has to come to the forefront of global agendas if at the same time we are going to mitigate the extreme global temperature rise we're seeing and meet the United Nations Sustainable Development Goals in their entirety. And with the increasing threat, this is an urgent need to tackle this issue. We need to work globally and collaboratively across all sectors to launch an effective solution and strategy to enable access to cooling for all. It does require an holistic approach to understand need and respond to them with appropriate technology, skills and training. And then it does require us to properly audit what we are doing. Thank you very much.
Thank you very much, Toby, for introducing the concept of clean cooling to our audience. There is a lot of short-term and long-term perspectives to be considered, and then there is a role to play for every stakeholder, from government to private sector. Can you please share with us your thoughts on what would be a recommendation to Southeast Asia, to Philippines, namely? Where is the best place to start? What are the roles of different stakeholders? Is this a government-driven initiative, or do you believe private sector has more role to play? Thank you.
So the first place to start is we have to start with a needs assessment. We have to actually understand how much cooling do we require to meet the Sustainable Development Goals. It's not good enough to simply have a projection of how many pieces of equipment we are going to deploy based on economic growth. We actually have to say we have set a target under the Sustainable Development Goals to address certain needs around economics, poverty, hunger, health, safety, with no one left behind. Until people understand how much cooling that requires, you cannot start to answer the questions of how we deliver it in a safe and environmental way. So that has to be the start point. At the same time, as I said, what we need to be seeing is, in parallel, we need to be seeing the immediate quick wins that business can take to make sure that air conditioning units are set at the right temperature, that where they are installing equipment today, it's using the lowest GWP refrigerants, it's energy efficient. We're thinking about cool rooms. But until we get our handle on the size of the problem, we're not going to actually come up with the right answer.
Thank you, Toby. You are involved in several projects around the world in Africa. I believe you mentioned India is one of the important markets they are looking at. Do you see similarities among the developing countries around the world when it comes to establishing this infrastructure, cold chain infrastructure, or every country, every continent has a completely different, let's say, the starting point?
So every community has a different set of needs. If I'm growing one product, it will have a different cooling requirement to another product. If I'm a fishing community, it will have a different set of requirements. But what we're looking to do is create a methodology which will work in all countries to help them understand their need, understand their available energy resources, not just electricity, but their waste heat, waste cold, all those aspects, and then bring them together in a financially sustainable way. So, for example, when we're looking at COVID-19 and the cold chain, we're working in Bangladesh at the moment to look at how we solve their challenge of meeting access to cooling for COVID-19 immunization. But in so doing, it will deliver a methodology to take to other countries. Every country has a different set of problems, but the methodology can be the same to capture and work through the process.
Thank you very much. We have a question from our delegates. I will try to display it, and I will also read it out. When it comes to refrigeration equipment, what type of refrigerants are you using? And how do you ensure they use low GWP refrigerants? A question from Australia.
So we use, as I said, the way that we work is that we don't say this is the refrigerant or this is the technology that you have to use, because you have to choose the right solution for the right application. So if you look at COVID-19, at the moment, we have the first vaccine is at -80, the second one's at -20, and we're waiting for the ones for 2 to 8 degrees to come out. They will have different requirements. But the way that we ensure they use low GWP refrigerants is the point of the audit, is that will set a key set of criteria around the refrigerant that if they want to get audited as clean cooling, they will have to meet. So that's the purpose of the audit, is that it's how do we transition from an aspiration to actually confirm that they are low GWP refrigerants, because then it enables the financiers to ensure that they are only financing projects which meet a clear set of criteria for clean, sustainable cooling.
Thank you very much. A final question for you, Toby. You have been involved in the industry and in this topic for many years. What personally drives you to keep working on the clean cooling and this concept for years to come? What drives you personally?
Well, you know, there are two. The big thing which drives me is it's really simple. I've been working here before this. I worked a lot in emerging markets, developing world, looking at challenges. I've got 3 children, and we have to make the world better and safer for our children. And that's about the climate environment they live in. It's about the global society that they live in. So at a very basic level, for me, it's about ensuring that my children have a better world to live in and a safer world to live in.
Well said. Thank you very much for sharing, and thank you for really introducing the concept to many stakeholders that are involved in this conference, but also in the projects like Cold Chain Innovation Hub in Philippines. We have identified a lot of opportunities, especially linked to the post-harvest facilities as a means to preserve the value and increase the well-being of the farming community in Philippines, etc. So there's a lot of ways that we can all contribute, and please keep doing what you're doing. I think it's great to have your leadership, and thank you very much again for joining us this very early morning, and looking forward to our interactions.
Thank you very much for having me, and I wish you a great conference. I'm going to go and have another coffee. Thank you.
Thank you very much, Toby. Bye-bye. you.